This is a WEG CFW100 Inverter Drive, and this is a 3-phase electric motor. In this video I'm going to show you how to set up the CFW100 to increase and decrease speed, set maximum, minimum or a fixed speed, and change acceleration and deceleration rates and direction of rotation. Hello, I'm Simon from the Inverter Drive Supermarket, and this is part 2 in our video series covering the CFW100 Inverter Drive from Brazilian manufacturer WEG. In part 1 we performed some basic commissioning steps to match the inverter to the motor we're using. We also ran the motor to check and correct the direction of rotation. So to pick up where we left off, let's start the motor. The display automatically changes to show the value of parameter P002 so we can see the output speed. As before, the motor is running slowly, 3 Hz, which is the default. This is the minimum frequency, meaning that the inverter won't run the motor at a speed lower than this, and it can be set in P133. To set this value, press P to access the parameter list, use the up key to select parameter P133 and P to select the value. In my view, 3 Hz is a sensible value for minimum speed, rather than 0, as it should be obvious when the motor is running and when it's stopped, so we'll leave it as it is and return to P002. To speed the motor up, simply press and hold the up key. The inverter won't increase the speed past 55 Hz. This is the maximum frequency and it can be set in P134. 55 Hz is a typical motor rated frequency plus 10%, but we can reduce it to 50 Hz, which is the rated frequency of the motor we're using. To do this, press P to display the parameter list, use the arrows to select P134 and press P again to edit the value. You'll notice that we can hear the motor speed decreasing as we reduce it. Press P again to save the changes. Select parameter P002 again to return to the output speed. Now we can use the up and down keys to set the speed to any value between P133, the minimum, and P134, the maximum. When I stop the motor and restart it, the inverter remembers the selected speed. This can be viewed in parameter P001. In fact, if I power cycle the inverter, it will still remember the previous value we could see in P001, which is the speed reference. The minimum and maximum speeds can be useful if you just want to run at a single fixed speed. You can set both to say 45 Hz, start the motor, and that's the speed it'll run at, no faster and no slower. If I try to set P134 to a value lower than P133, the inverter returns a conf or configuration error. This is to be expected as our maximum speed must be higher than our minimum. A small arrow is then shown on the left to indicate that there's a conflict and it needs to be fixed. Press P to acknowledge. The display is capable of showing up to 2 arrows representing 2 conflicts. Return to the parameter to correct the value, the arrow then disappears. Select parameter P002 again to see the output speed. Now start the motor. It accelerates to 45 Hz and won't go higher or lower. Now return the minimum to 3 Hz and maximum to 50 Hz. Now we understand how to set the speed, we can move on to acceleration and deceleration. The time taken for the motor to reach the maximum speed is a bit slow, and the time taken for it to stop is very slow. We can adjust both of these if needed. P100 is the acceleration time in seconds. The default is 5 and it represents the time taken for the inverter to increase the speed of the motor from 0 to the maximum frequency set in P134. P101 is the deceleration time in seconds. The default is 10 and this represents the time to decrease the speed from the maximum frequency to 0. In both cases they're proportional, so when the deceleration time is 10 seconds it will take 5 seconds to slow from full speed to half speed. And if the acceleration time is 5 seconds, it'll take a second to accelerate from 40 Hz to 50 Hz. So let's change both to 1 second and see how we can make the motor more responsive. Okay, let's start the motor and see how quickly it accelerates. It's now much quicker. The deceleration time is quicker too. In some applications, the deceleration ramp may not be required at all. For example, when the motor is connected to a low inertia, high friction load. So, parameter P229 can be set to 1 to change the stop mode to coast to stop. Just as it suggests, this causes the inverter to cut the output immediately so the motor will simply coast, eventually coming to a stop. Let's try it out. So we now know how to start, stop, and change the speed, acceleration, and deceleration of the motor. To change direction, we can edit parameter P223. By default, this is 0 for always forward, clockwise, but we can change it to 1 for always reverse, counterclockwise. When we do, you'll see that the icon on the top left of the display changes accordingly. If I return to P002 and reduce the speed, we can see that the motor is now turning in the opposite direction. The final parameters we'll cover in this video are P220, the local remote selection source, and P224, local run stop selection. By default, both are set to 0 for always local HMI keys, which means the start-stop and up-down buttons on the inverter are used to control the motor. This is the control we needed for this video. However, in part 3 we'll change P220 to always remote so we can connect the digital I/O terminals on the inverter to external buttons and switches. There are several other options for both parameters, but it's not necessary to discuss these at this stage. Although we've been using the keypad to operate the motor, it's really only intended for commissioning and not as the primary source of control in a production environment. In many cases, the signals to start, stop, and control speed and direction will come from external push buttons or another remote system. Okay, that's it for this video. Thanks for watching, and I hope you'll join me for part 3, where we'll explore motor operation in remote rather than local keypad control using the CFW100's included digital inputs. If you found this video helpful, please give it a thumbs up and consider subscribing, as we really appreciate your support. See you next time.